this embedded system, hardware and embedded system bootcamp. Though this session is not from, we are not going to be discussing about our syllabus from the 11 weeks bootcamp. Where it's just like a bonus, knowledge, additional knowledge to the hardware and embedded system, which might not be taught in the normal 11 weeks session. So I welcome you all here to our class about H-bridge, which have the description of control and applications in embedded system, because everything we are doing is what is in respect to embedded system. And we are also thanking our host here, Mr. Samuel, for making this session to be possible for us. So let's not bother with the secondary screen. Let's just start. Let me start sharing my screen because I have a slide to present. Alright, I've started sharing my screen. If you cannot see, just raise your hand and I will know. So I will start with the presentation. So as you all know that today's class is about H-bridge control and applications in embedded system. The control and application of embedded system of H-bridge and embedded system. So before we talk about H-bridge, mostly in embedded systems, why we apply H-bridge is for DC motors. And DC motors are what do you call it? Adjustment, tweaks, applications and stuff. So first of all, we need to know what DC motor is and talk more a bit about DC motor before we explore our H-bridge and talk about our H-bridge. So what are motors? Basically, now we are talking about DC motors because we have several types of DC motors. So in short, just DC motors are electromechanical devices. When we say a device is electromechanical, what we mean is just that that device operates in electrical manner and also in a mechanical manner. That means what it is not fully mechanical and it is not fully electrical or electronical. So electromechanical devices, they need excitation, that means input of a DC source or some source, electrical source, for it to operate mechanically, or it outputs mechanical electronics output once you give it an input of what mechanical input. So why do we need motors? Basically, we need motors to perform some movement operations because there are some things that need to be moved. Some requires energy, some doesn't require, but we need that movement to be remote. In our embedded systems, if we say we cannot move something from point A to point B in what? In fully electrical or electronical. It is not possible. We need to require a mechanical force that will do that movement for us. That is why we need motor. What role does it perform? Basically, motors used to replace manpower actually, because when you see it in this way, for example, now uh, lifting of some heavy stuffs that we used to use motor, or our lifters now. When you use lifter in some skyscrapers, it's all the application of motors. So they used to sometimes replace manpower. So we used to replace instead of you to move from point A to B, in order like to open a door. Let's say you are lying on your bed, you don't want to open door and someone is knocking. So from just there where you are lying, a motor cannot do that job for you, can open a door for you. So you see, you are just resting. And so I don't want to go into details, but this is just the operation of the motor. This is the link below are the references for each image. The first link is for the L298, and second link is for the Fleming's left hand rule. If you want to explore this thing much further, you can go to the link or maybe go and Google about the DC motor operations, because we don't want to waste much time on the operations. You can see it's just a very simple straight something that what a current carrying a conductor carrying a current what produces a magnetic field. So if you put that coil inside a magnetic field, they will interact with each other, and watch some actions will happen, either to repulse or to watch to attract. And with the help of Fleming's left hand rule, you can know that if a current is applied at so direction, the wire or the coil is supposed to rotate at so direction. So you can explore this, and I will share this slide once I'm done, so you can study it much further. So we have the speed of the DC motor, because a motor is what? It's a device that would produce a rotatory mechanical output, right? When I say rotatory, that means a rotatory motion, right? As revolving something, so that what it completes a single oscillation, what uh, over and over again. So without moving from point A to B, it's just standing in a particular position, just what rotating. So that speed of DC motor, that means what? It has a time taken for it to to cover a single cycle, a 360 degrees, right? So because it spins so fast, so we cannot just count it as as saying this is the time it has taken to complete one cycle, because the time will be millisecond sometimes. So that is why we used to calculate the speed of the DC motor in RPM. The RPM is the revolution per minute. So we used to calculate the speed of the DC motor in a revolution per minute. That means that in one 1 minute, how many times does the motor complete at 360 degrees? So that is how we used to calculate the speed of the motor. And the speed of the motor is very essential, because once choosing a motor for a specific application, we also the RPM, that's the speed of the motor, is to be considered. It's very important. So we have the direction of rotation as how the speed of the motor is very important. The same thing for the direction of the rotation. The direction of the rotation is also important, because what you need the motor to rotate in a so direction for your application, right? So we have the counterclockwise. Sorry, I wrote it in abbreviation. I should have wrote it full. We have the counterclockwise. Sorry, we have the clockwise and the counterclockwise direction. So this, as I talk of the speed of the motor, I'm also going to talk about the direction of rotation. When we saw the clockwise rotation, it's obvious, right? Just the motor turning in in the clockwise direction. And we also have what in the reverse direction, which is what counterclockwise direction. I wrote how like how does it perform. So actually I'm going to just explain it very brief, because if I'm to explain it much further, you need to understand this concept. This is how the motor operates before you understanding the how the how concept. So I'm going to explain it. Even if you didn't understand this concept, you will be able to understand how does the motor um, how is the motor able to uh, spin in the clockwise direction and also in the counterclockwise direction. So the clockwise direction is the normal direction of the motor. That means that when you buy a motor, a DC motor, the motor used to have what positive and negative terminals, right? For you to power the motor in order to the motor to rotate. So that positive and negative, why do you see positive and negative there? Because it is a DC motor. If it is not a DC motor, there is no way you say that positive and negative. It is not possible because an AC motors, the AC motors doesn't have anything like positive, negative. So in normal circumstances, when you plug in your positive terminal, before even powering your motor, you need to know the voltage rating, right, or the wattage rating, or whatever. So if you know the voltage rate, if it is a 5-volt motor, you need to find what's a 5-volt battery or a 5-volt DC supply. Carry the positive of the motor, plug it in your in your positive terminal of your battery, also the negative of your battery. In that way, your motor will spin in the clockwise direction. That is the normal way of the rotation of the motor. The counterclockwise is the reverse rotation of the motor. Once you leave that your connection as it is, the positive at the positive, the negative at the negative, then you only take your battery and rotate your battery 160 degrees. That means that you have reversed the polarity. Now the negative terminal of your battery is connected to the positive terminal of your motor, as well as vice versa. So that means that that your motor will spin in the counterclockwise direction. So you see now we have got a reverse direction of our motor. So if you want to keep on changing the direction, you just need to be what? Either changing the polarity or rotating your battery, or what? Twisting your wires, carrying your wire from this point to from point A to point B, from point B to point A, and continues. That is when you'll be getting this reverse and forward direction. But that is a waste of time, right? You cannot do that forever. You need some system to do that for you. That is why we need what? The H page. So we have the speed control. Speed control is very powerful. Like, when we say control, it's the word itself, control, is very powerful. Because when we say you can control something, you have control over something. That means that what you can do whatever you want with that something, right? So control is very important. Not to mention in motor. When we say speed control, once you have the control over the speed of your motor, you can change its application. You see the first content I wrote there was what? Expand the scope of potential application. Just by gaining control of the speed of your motor, once you will be able to control the speed of your motor, you can increase its application. Because let's say maybe you buy a 5-volt DC motor that you attach a propeller to it, maybe to fan something, maybe to take out heat from from a device, or maybe to just cool something. So by just gaining that speed of control, because there are some applications that you don't need high speed of motor, you only need low speed. So you see that now this motor have initially the motor have what application of high speed. So if you can be able to obtain a low speed from that motor, that means what you can also apply it in places where we need what low speed of DC motor. So it's very powerful, this speed control you are saying. Not to mention that just because you have a low speed doesn't mean you can make it what increase the torque, right? Because if you have a low speed, because used to need the places where we used to need low speed of motor is what is a place where we need what high torque. So just by decreasing the speed of the motor doesn't mean what you acquire high torque. No, the torque doesn't change. What happens is that you need to make some combination of gears in order to gain high torque, because we know what torque is, what is force times distance. So you need to increase the distance between the the output, or the immediate output of the motor, that's the head of the motor. You need to add some gears, small gears, big gears, do the combination properly. There are formulas to do that. Calculate the number of teeth required, do the calculation. As long as you obtain so many gears, you will see that what the end point where the motor is delivering the work done, you will see that it has a distance to what, to where the motor, the head of the motor, the initial head of the motor, acquire some distance, which is the multiple of the force. Now the force will be multiplied by that distance and will get a higher torque. That is this, what I finished saying is the what is the mechanism of servo motor. Servo motor is just a normal motor inside with a very low torque that cannot perform any powerful operation or produce high torque. But that box of the servo motor you are seeing is just a full combination of gears. Sorry, let me see if we can see an image. I don't know if they can show us the inside of this servo motor. You see it here, right? Let me get my magnifier. Hmm. You see it, right? The motor is below. They didn't show us the motor. The motor is down here. That what you see the combination of gears. That that means what, the mechanical energy is being transferred through these gears before it reaches what, the output. This is our output. So now this combination of gears helps this our initial motor to produce much more power than it can produce before. So that is the this is the mechanism of servo motor. So it's very powerful something. You gain power from what, from increasing the distance from the initial place to the work done place. So from there, if you do the combination properly, because there are some combination if you do, you can reduce the power of the motor. So you need to know how it works. So the next thing is high demand in applications. So by just, you see what I just finished saying, by just having control over the speed, you can what, use a motor to build in what, servo mechanism, stepper motor mechanism, and so on and so forth. Because even the servo motor I just finished explaining is just a basic motor. So you can easily build a stepper motor also with a normal motor if you do the combination right. Okay, and also with the help of what, with the help of a driver board, because you cannot just do that combination of gears and stuff just so on and just leave it. You need to provide an integrated board that will what, that will be regulating the operation, because it needs to be operating in what, in pulse width modulation. So you need to design a board, a circuit board, integrated board for that your mechanism to provide that application for you. Because it is not all everything that you need to be buying. You need to sometimes construct something for yourself. Even not just servo motor and stepper motor, with this mechanism you can construct other things that will be that will play important role or provide real world solution in some what do you call it, mechatronics applications. So we have the control. There are some instances where you have the speed control. There are some instances where you have the direction control. There are some instances where you have the speed and both the speed and the what, rotation control. So as you can see how powerful gaining the speed control is, also the direction, getting the direction control able for you to be able to be powering your motor in reverse and forward direction. It is also powerful something. So what do you think will happen if you have the ability to do what? You have the ability to control the speed and the rotation. That means that that motor is completely yours and you can gain varieties of applications from it. It can be applied in uh, um, so many fields, right? So it's very important to know that is the purpose of this session, for you to be able to gain speed control of your motor and also the rotation of your motor. So simplicity, we have gained the simplicity, had controlling, being able to control the speed of your motor and being able to control the direction of your motor is very complex something. It used to be very complex something that used to take you time and time and stuff. But what, with the help of MOSFETs and transistors, MOSFET transistors or drivers, motor drivers, we have gained what powerful control over our speed and direction. Uh, I just can't explain how this MOSFET and these drivers used to help us in uh, how drastic they provide us the simplicity in controlling our motors and directions. Like they play important role because with this MOSFET and drivers, simply in easy way you can just what gain control over your over your motor speed or your motor direction. That is what we'll be looking in this session. Excuse me, please.
Okay, okay.
Hello.
Hello, we can hear you.
Okay, my network just went down. Okay. Uh, Let me just. It doesn't want to show. Let me just check. Let it. Thank God I've downloaded it. It's let's manage with this. This one. It's not good looking. It's not. Let's just manage with it. So with this, with the help of this MOSFET and drivers, that is where we get to gain access to control. So even this H bridge we are seeing, it's being constructed with the help of MOSFETs or drivers. Even the drivers, they got inbuilt uh, MOSFET in them that used to, because I think there is no way you can get motor control, you can get a motor driver that doesn't contain MOSFET in it within it. So MOSFETs are the most important ones, or I should say transistors in general. So we have the H bridge. What is H bridge? So H bridge is just, let me just quickly do five because we need to do some demo. We need to do some demo, and it's almost an hour now. So what is H bridge? H bridge is just what? It's just a combination of some MOSFETs and Yeah, some MOSFET, some mini circuit like that provides you the control of both your speed and and direction of rotation of your motor. So as you can see in just three words, we have our motor, our watch bridge to be defined as what? As a motor control circuit. It has some other applications, but the basic application of the H bridge and in this course is going to talk about motor control circuits. Why do we need it? To control what? Motor direction. And what role does it perform? It facilitates motor control. Like it gives you the easier way, the best way towards to get control of your motor. So this is one example of our driver, of a motor driver that used to what provides real world sorry, not real world, that used to provide H bridge uh, operations, because we have different types of motor drivers. Like the stepper motor we used to use, it also have its own driver, but that driver is not just a H bridge, but this one it's a what? It's a H bridge driver that provides you the access in your building your robotics something, because it can give you access to power your motor either forward or backward, or uh, to adjust the speed with just some few lines of code. That is when, if you are willing to program it. And one thing with this driver, you can also use it without even programming it. Like you can use it analogically, like you can program it manually. When I say program it manually, that I mean that what, you can be using physical switches on breadboards, putting some jumper wires and doing the operations manually. And you can also plug that pins to your what, Arduino pin, and just program the Arduino to be doing the adjusting or the switching for you. So we have what we call the pin outs. This is the pin out of the driver. It have uh, several pin outputs. It has the motor A, because this driver is meant for two motors. You can control, yeah, that is one additional advantage of this driver. You have two outputs, you can connect two motors, I mean, because H bridge is just meant for what? For a single motor. But this driver provides you the ability to what? Gain control over two motors at the same time, which is very important. Because now if you want to construct a robot, some robotic something that has two wheels, so you don't need to buy two drivers for each wheel. Just a single driver can do the work of two drivers, which is very important and very attractive. So it has the motor power. You can there is a pin for you to provide the voltage that will operate, that the motor will be operate. That means that if your motor A and motor B operates at what, at 5 voltage, then your motor power will be what, will be operated at 5 voltage. Sorry, let me rephrase what I said. If your motor A and motor B operate at 5 voltage, that means your motor power will be 5 voltage, or I should say the motor voltage should be 5 voltage. When I say motor power, I'm referring to this pin. So if your motor A and motor B operate at 12 voltage, your motor power will be 12 voltage. But you can decide to neglect this 5 voltage, because you can see it's optional. We have a common ground for both the power. That's the power, the motor power, and the 5 volt option. So this jack here is for the motor B output. Your motor B will be connected here, as it will be gaining, it will be being controlled from the board through this pin. So you can see the source of this image is the drum board workshop. So it's not me that designed it. I just find it easier to get one uh, to demonstrate for you. It has a 5 volt select jumper. There's a jumper that you can use to, because you see this 5 volt is optional. So if you use this jumper, you can decide either to use this 5 volt or to use the motor power. So this is L298N driver. It is a very popular driver. It has various applications. If you just search H-bridge on the internet, you can see without even specifying the body, you must see this board. It's very popular in H-bridge applications. So we have the motor A. We have some tiny pins which the image is not clear for you to see. It has some few pins, 5 pins here. We have the motor A enabled, the motor A input 1, motor A input 2. We have the motor B input 3, the motor B enabled. Okay, sorry. There is a pin that has not been stated. We have the motor B input 3 and we also have the motor B input 4. Then we have the motor enabled. So that is the pin out of the so that is the pin out of the uh, driver. So this is the circuit we'll be using to do the demo. This is the circuit we'll be using. Don't mind the circuit. So we'll be doing the demo will cover simulation and real part. Okay, I'm so sorry. Up to now my secondary device it's not connecting. It seems like my Teams. Let me uninstall my Teams and install it. Okay, let's go on as that one is taking place. So we'll be doing the simulation part and the real part. Okay, so the next thing we have for the simulation will cover the basic of H-bridge. How does a H-bridge? Now I think my secondary device will get connected. Yeah, it has. Okay, hope you are seeing my screen because from my secondary device I cannot see the screen.
Yes. I can see the screen.
Alright. So we will cover in the simulation part. We will cover the basic of H-bridge and driver, which is the L298 driver. And the reason why I will be using the simulation part to do the L29 driver uh, operations and stuff is because I don't have the driver. I didn't own one, so I will be using the simulation one for you to see it. So the next thing is for the demo reel, which is the real one, we will be displaying powering a motor because you can't. There is a way to power a motor, like it is not just to plug in terminal A to battery and terminal B to negative battery to power your motor. You can also see how to gain speed control of your motor. So before we get further, any questions? Any question, please, before we continue? Any question, please? No one. All right.
I'm not sure there's any question.
Sorry.
I'm not sure there's any question.
Okay. So I think let me see which one for us to start because um, the objectives of the demo will determine which one for us to start. I think we'll start with the real one because we need to know the power, how to power our motor, and we need to know how to gain speed control of our motor. So before we power our motor, the first thing for us to do is that let me just because there is something I need you guys to see clearly. So if I show you on camera, you won't if I show you on camera, you won't be able to see it clearly, so I will take the advantage of the simulation. Okay, so let me do this quick. I've almost elapsed an hour. So to power your motor, the best way to power your motor is for you to make use of combination of a diode, the motor itself, the source, and the and a transistor, because this will provide you the best way of powering your motor. Let's take a transistor. Let's take BZ527, the most common one. It's a bipolar, I think NPN, yeah, bipolar NPN. Uh, we're gonna need a diode that is a drive. Let's use the one at 4007. Yeah, it's also a good diode for practical applications. So let's use a motor. We have a DC fan here, but it will be better if we use a normal motor. Please take note when selecting your let me on my magnifier. When selecting your device when doing simulation, please be taking note of these descriptions, because some devices are not meant to show outputs. They are just meant to show a schematic something. Now let's see example of this one. It's just a schematic model. It's just a model. It doesn't. If you power it, it will not rotate. It will not show any sign of rotation. But once you made use of this animated something, you see all these ones. If you power them, they will show some output. So be taking note of which device to choose. So, oh my God, see one for Newton. Like I've been using this magnifier. It's just now I'm seeing on my secondary device that the magnifier is not showing any effect. Right now my screen has been zoomed in, but at the output I'm not seeing the screen being zoomed in. But just forget. Let me turn off the magnifier. So the next thing you need is your motor. Okay, I don't need it like this. I can rotate it. Okay, you need your motor. Just connect your motor. We need okay, let me delete it because we need to finish importing our devices before. Then let's say we need a resistor. We need a resistor, then what? Then a ground and power. You need a power and you need a ground. Now this is the best way to connect your best. Sorry, it's not going to be like this. Let me rotate it. 180. Oh, sorry, not 180. Okay, I don't need to rotate it. Sorry, I just need to delete the computation and this. You just need this is your base resistor. That's RB, right? It's going to be connected to it, to the power. Then your motor is going to be connected to the power as well. Then to the collector of your transistor. Your emitter will go straight to ground. Then your diode to be connected to the power as well. In parallel to your motor. Why do we need this diode? Is for protection, because we use this diode to protect our transistor, because it's an motor has magnetic field and stuff. So once it get turned off, it can easily send a high voltage to your transistor that can lead to the burning of your transistor. So with the help of this diode will take in that high voltage that has been sent from the motor towards this wire and back to the source, which will not do anything to the source. So you can do this, do this, do this, do this. You get your power. This value is too high. Oh, let's leave it at that. Let's use 12 voltage and power. I think our circuit is complete. Maybe generator might see. You see our motor just rotate, right? But what? But in negative, let me tell you, in negative RPM, because what? I did not arrange the polarity in the conventional way. So I plug in this motor in the reverse direction. That means that this place is the positive, is the negative of the motor, and I'm powering it through the negative. So if I'm to rotate this motor, this number will become positive. So and we don't need to waste too much time on this, right? You can just stop the simulation, rotate your motor, and just do 180 degrees. Now that is what I was talking about, changing the direction. You see now once I change the polarity, you see now the motor is turning the other way. So you don't need to be rotating the motor, like you don't need to be changing the polarity manually. Like the driver can do it automatically. So you see now the basic way to power your motor. If you want to power your motor, this is the best way to power your motor. If you have gotten the rating of your motor to be able to reach, let's say, 1000 rpm, and you power your motor and you find out it is not reaching up to that speed, or the speed is not satisfying for you, what can you do? You can see now we are gaining a maximum of what, a 102 rpm, right? So if you want to increase that, you can reduce the value of what, of this resistor. Let's say 5k. Okay, it's not playing. If you reduce this resistance, this motor definitely will reach a higher speed, because you are increasing the amount of excitation at the base of the transistor. The motor is not rotating, but that's it. You need to be adjusting this resistance in order to gain much higher speed uh, of the motor. Because but at some time, if you reduce this value too much, if you reduce it much, definitely your resistor will get your transistor will get pumped. So you need to know the data sheet. You need to get the data sheet and know about your transistor. So let's now you have know how to power a motor without damaging your transistor, or without damaging your motor itself. So let's see our slide, right? The next thing for us to cover is the speed control. So I said all of this should be demo, right? Let me get my circuit ready here. Okay, let me just, because I've already for you to, let's do it here, because the circuit, I've already made the circuit, so it's like I'm just showing you the demo without knowing how I do it. Let's use the Arduino Uno. We're supposed to use the Nano because it is small and rotate it. Okay. What I did was just to carry out my Arduino, get in my what do you call it, motor. Okay, I've imported it earlier. It's supposed to be here. Then get in my motor, get in my potentiometer. Okay, this one is just a model, I think. We need to find the one that can be. Yeah, the resistor to not easy. I think this one I cannot be able to adjust it. Yeah, I can't. I want to get a variable resistor. Can someone help me with the name? I can just search in to get a variable resistor without wasting too much time. I forgot the name. Okay, let me try writing variable. Okay, resistor. Nothing happens. Okay, see them. They are all schematic models. I cannot change them. There is the one that you can change. I can tell by just seeing this place. Okay, let me just not waste time. Let me take anyone. So I get my potentiometer, which have three legs, right? Let me rotate it. Take it here. Give it a 5 volt power. That means I connected it to the 5 volt of the Arduino, and I have given it the ground of the words of the Arduino. Then the output of the potentiometer, I connected it to A0 of the Arduino. The next thing I did was to carry a MOSFET. The type of MOSFET I used was, I think it's 3205. I put it in my MOSFET. Then you need to make use of AWM pin output by, you can identify it by what? By seeing this line, a sine wave line, like a sine line. It's the one outputting, it's a pin capable of outputting pulse width modulation. Then I power it directly to the base of my resistor, MOSFET. I didn't make use of any resistor to protect my MOSFET because the Arduino is can be able to do that for you. And the output current of the Arduino pins are very less for it to burn your MOSFET. So you can take the risk and do it because I didn't insert any. So I connect my the negative part, that's the negative terminal of my motor to the what do you call it for that MOSFET? Is it drain? For the drain of my MOSFET. And also this is our gate, right? This is our source. This is our what? Drain. Right, if I'm not mistaken. I don't want to give you false detail. Okay, it is okay for me if it is me alone, but this is uh, okay. You see, I've interchanged it. The above is the source. So here is our source. Here is our drain. Here is our gate. Instead of collector base emitter. So I get my power. Put it here. Yeah. Then put my ground here. I didn't even put that diode that used to protect the, what do you call it? I think it have the diode. I think it can be protective itself. I think we don't need to put the diode. Maybe I'm not sure, but maybe this is a very small circuit, small motor. So I'm not. It cannot burn my transistor, my MOSFET. Maybe if it burnt, it's like it's but so the next thing I did was when adjusting this potentiometer, potentiometer now, the one with three legs. Once adjusting it, The Arduino will be taking the reading here. We did it in our last class, right? Doing the mapping, it will be taking zero from value from 0 to 1 or 2, 3, and doing the mapping from 0 to 255, and then outputting that value to the base of our transistor in order to power our motor. With that, we can change the speed of our motor. So this one I just show you the circuit, because now I will just power the circuit. The circuit is already connected. So I will just power it. Let me see. Any questions so far before I finish setting up this thing? Any
Mm. What if you use the former connection? Is it going to work? That transistor.
a normal transistor?
First, when you use it, only power zero.
Yeah, a normal transistor. It's absolutely going to work.
Most of the people have. Okay, okay.
S- Yeah, a normal transistor. Sorry, I didn't mention that. I just like using MOSFETs. Okay, I like using MOSFET, and basically I kind of have much more MOSFET with me in my workshop than transistors. So in case if I burn one, I get another one to use so frequently. So that is why I mostly like. That is why I get to like MOSFETs more than transistors, because transistors are much more sensitive and easy to get burned and stuff. Or some people might say MOSFET, but no. This is the circuit. I think the code. Yeah, I think it's the last code I wrote. I wrote it earlier because to avoid wasting time, so that if I come, I will just explain how it works. I define my potentiometer port. I know it's too small and I can't zoom in. If I use my magnifier, it will not zoom in, and I don't know how to zoom in from the settings or something. But I think you can see. Let me just explain. So I define my potential port to be A0. I define my control pin to be pin 3, which is a PWM output pin. I set in a variable to store the value that will be outputting uh, at the base of our transistor. I first of all declare my control pin to be output. I declare my potential pin to be input because we'll be taking an input. I digital write my control pin to be low initially. I also analog write my control pin to be 75. Okay, this was the time when I was testing it, so I will just comment it. I will remove it. So don't mind with this line of code. So the next thing we get when we get into our code, I take in that variable that we initialize here at the top, and I assign that value of potentiometer that will be getting into that variable, then mapping that value from the range of 0 to 1023 to 0 to 255, then analog writing it at our PWM pin, which is control pin, which is pin 3. What will it be outputting is the value that we have read and was mapped uh, during our loop. Then it will just do a delay of 20 milliseconds, which is a very small delay, so that the response of tuning our potentiometer will be the response of the Arduino after tuning our potentiometer will be so fast without wasting too much time for it to change the speed of the motor. You will be surprised if you see what I will be using as the motor. Please don't be surprised. Okay, let me check in just say ready. Uh, Nice. Then let me stop sharing my screen here. Okay, no more sharing. Then let me share my screen here. and a secondary device. Oh, sorry, there's the screen. Yeah, okay, yeah. My screen is not getting shared, and where's my camera? Mm-hmm. Then on my flash, to okay. Maybe the flashlight is. Let me try to turn it off. I don't know which one is better. Let me just use it. So this is it. This is do you know this is the connection, and you have already seen the circuit. Okay, this one is breaking. You have already seen the circuit. That is the purpose of the circuit. You can see three potentiometer here. So I'm using this potentiometer. Please don't be confused. This is my MOSFET here. Is the IRF 3205. This is the motor I will be using. So you see my motor here. So you will be surprised why I'm using servo motor. I'm using servo motor because this servo motor is not an ordinary servo motor, because I've been using it for a while, then it got spoiled. Once the servo motor got spoiled, I opened the servo motor and do some setup that will make the servo motor to behave as motor. So that was the first time when I see how the servo motor works. There is the mechanism of the servo motor is very very interesting, very interesting. Like I learned many things from the inside of the servo motor. So I was able to do my servo motor, but this servo motor, the way it behaves is just it spins 360 degrees. That means that if you want to make use of it to, okay, let me be straight from above. If you want to use your servo motor to this servo motor, I mean, if you want to use this servo motor to operate as a normal servo motor, you can still do that. Why? Because you can do your coding. That is the powerful of what programming. You can program your Arduino to make this servo motor behave as normal servo motor, even though this servo motor it is behaving as a normal motor. So now, before I even on this motor, let me show you. If I just take in the okay, if I just take in the if I just power the motor, just see what will happen. Where is the ground? You see? If I now I just power the servo motor, you see what is happening? The servo motor is just rotating 360 degrees continuously like a normal motor. I can see the demo is scratching. The demo is lagging. It's not following along. So you'll not be able to see these things, right? So now I've finished setting up my circuit and everything. Okay, let me remove this phone holder. Just hold my phone up. So now this is the potentiometer. You'll see now the servo is currently at the initial position. If I start tuning it, you see the servo motor started turning very slowly, right? It's turning nice and smooth. You cannot see the smoothness because of the this thing. So if you turn it fully anti-clockwise, now I've maximized the speed of the servo motor. Now the servo motor is rotating much more faster. I can reduce the speed up to a stop. Now the servo motor has stopped. So you see. I just thank God for using this servo motor to demonstrate, because if I'm to use normal motor, you know normal motor is very fast. You cannot be able to see it with this lagging of the of the demo of the what do you call it? Yeah, of the demo. So now let me stop sharing and start sharing. So now you can see how I was able to get a smooth speed speed control from my Arduino, just using my MOSFET and my Arduino. So the next thing to do now is just to what's next on our slide. Now we have seen how to power a motor. We have seen how to get a speed control of our motor. Now the next thing is what is the simulation part. Oh, I'm not sharing my screen. I just went ahead and hello. So I really having problem now because you can see. Oh, you can't see. Sorry, I am not in my camera. You can see my my PC just ran into a problem and show me a blue screen, then start getting restart. Oh my god. So I have to wait. My PC just so any questions so far? Hello, any question?
I was thinking that it's that day when you came back from
No,
class.
no problem.
Me, but I was thinking, I was even thinking, I couldn't see it.
I was not expecting this. Yeah. Please, any question? If there's any question, and you have the opportunity to ask now, and we can discuss about it much in detail uh, before what do you call it? Getting back to the simulation part. Why is it taking too much? Okay, maybe it's because it ran into a problem. I don't know what happened. So just instead
What's
of
wrong with the
staying
laptop like that?
like it just show me blue screen and just went
Maybe it got overloaded with work or something.
like I didn't used to experience it. I'm so surprised that it showed me this. Because even our last session I overloaded the PC much more higher than this time around. So you have seen how we can use of HBRI. You can also use H and okay, sorry, you want to ask question?
No, 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 no.
So also use which in inverter control. Uh, Between this nowadays, where you can achieve a sine wave output from an inverter. When I say inverter, I'm talking of uh, what do you call it? A power inverter that used to supply AC voltage to AC voltage to our households and apartments and so on. So when designing one, you must need in order to get a pure sine wave output, because we use simple and we get what do you call an output square wave or modified sine wave. Once it comes to sine wave, it used to be able to achieve that. For you to achieve that, the sine which to the data is very super very complex than this of a motor. So this of the motor is just the base. So that is sorry, mic is on. Stop.
Everybody know. They teach you with your mother tongue, you can understand.
Yeah, but I don't know how this works. Honestly, I'm not paid for putting my Look at this doctor man, you know, how would we doctor everyone outside? The body they at this boy, no, you know why they should because as my first time, they continue. Tell me, why your body they sweet.
Does not come up.
It has come up. You know, my hard disk is it's kind of dull, you know. So whenever my computer on, it used to take some time. That is why I like SSD computers. You see?
Well,
Oh my god. Like I don't know what to do now because I've never experienced it.
so this like crashing. Just leave it, and mm, it's like this laptop is crashing. So just leave it, and I've
Like,
seen something like this before. Especially when the laptop is somehow overloaded or the memory it's ran out of memory or so.
okay.
Or if the memory is getting low, I mean, if the memory is getting low, it used to happen. So
Okay. Yeah, blue screen, yeah, it used that. So I don't know what should we do now?
I think we have almost covered most of the part, both the simulation and the physical demonstration. So
Yeah, we have done with the slides, we have done with the major concepts. We and seriously, it's going to take long before booting.
so you can just maybe round off the class.
All right, so you have seen how we can get speed control of our motors. You have also seen how Sorry, I didn't include PWM in my explanation, but PWM is very important because all this speed control and let me just stop sharing this. All this PWM sorry, all this control and so on, you cannot achieve them without using PWM signals. Here, the PWM signals are just so powerful and important because we apply them in so many control circuits. Control is very important, and because when we say control, taking control of or something, what do you call it? Control engineers now have a very high opportunity rate because they can be useful in so many cases. We can't do now without control engineer because everything needs to be controlled. And when we say control, we mean like about 100% taking control of something, a system, right? Because we need to be providing what systems that can take care of that control for us without us human doing it. Because now you can have a very large apartment with hundreds of floors and what do you call it? Thousands of home appliances, equipment, devices, and so on. So if you say you are going to provide people that will be supervising their apartment, going room by room, providing services, checking in temperature, everything. So it's going to be very, very inefficient. And at the end of the day, you'll be spending much more money in compensating those providing those services. But you can get an automated system that can take care of that, checking temperatures, providing some services, IoT and stuff. So from there, you can see that you have provide a very large efficient system to take care of some real world problem because it is regulating what do you call it, the light intensity due to the time or due to the amount of light we have at that time, regulating the apartment temperature, doing some 2 to 3 things and stuff. So control is very powerful something. So I think for this class, I believe you have learned how to power your motor, how to control your motor, how to make use of H-bridge in order to, because I've explained to you, right? Just try and do it yourself. I've explained it to you how to get a reverse direction of your motor because you can just simply just change the polarity. So that is how you can reverse it. So you need to use either a driver or to build in a system using combination of MOSFETs. That will be what? That will be because or MOSFETs or transistors. Because just transistors are like switches. So it means that if you close this switch, current will flow to point A. If you want to flow from point B to A, you can change you can think of it and try adjusting some switches, play with it, and see. That is the importance of the simulation. You will not be afraid to burn any circuit or any resistor or some other transistor or something. So you can use your simulation software. More especially this approach is very friendly. You can play with it and try getting some outcomes of this motor. The applications of it is that you can apply it in robotics. Uh, you can apply it in inverter construction. But the main purpose of this embedded class is for the robotics, because sometimes you will need to make a system that needs to move from point A to B, or need to open a door for you from angle 0 to angle 360. You can do that without even need of servo motor. You can power a motor to turn at that angle with a combination of gears to reduce the speed of the motor. Because you cannot just use a combination of gears to just increase the torque. You can also use combination of gears to reduce the speed of a motor. If a motor is spinning very, very fast, you can put it a very small gear on its head to be spinning be spinning a very large watch gear. So from there, you will see that before it makes that large gear to spin 360 degrees, that what do you call it, small gear needs to spin at what, over maybe 30 times before it makes that big gear to spin one time. So you see you have reduced the speed of the motor. So with that, and you did not you even increase the torque, you reduce the speed while increasing the torque. You see how important all these gears and stuff uh, they are. That is why we usually used to used to lose all we computer and communication engineers usually uh, used to lose to mechatronics, because once it comes to all this embedded and stuff jobs, they used to hire mechatronics. They mostly hire mechatronics engineers rather than computer and communication engineers. So I'm just so jealous to say, but it's all right. Even
Okay.
though, okay,
No. I wanted to also ask, let me just throw more light on it. I know of using HB to control normal DC motor, but the HB, do they have application in controlling servo motor too?
sorry, I didn't get you. Like,
I know of H bridge is I've used H bridge in controlling DC normal DC motors.
okay,
Maybe to change the direction and the speed. But no H bridge, do they have application for this for servo motors too?
no, it doesn't have application for servo motor. It doesn't have application for servo motor because the the H bridge, you are using a driver, and that driver, it has its own purpose. And the servo motor itself, if you open it, there's a board, it has its own driver. So it's just like you are trying to make a driver control another driver, which is not possible because they are not related. So that servo motor driver has its own mechanism that is far different from that of H bridge, because servo motor is only meant to turn from 0 to 180, so not a 360 spin. But that of the L298 is meant for controlling a 360-degree spin. So in order for you to make a driver that will be controlling a servo motor, maybe you have to find a servo motor that is just like mine, that is spinning at 360 degrees. In that aspect, you can make use of the, what do you call it, the L298 to get a reverse direction of the servo motor. So I think that's if I don't think if I will answer your question.
Yes, that's the answer. Thank you so much.
Any question? Mr. Abdul is not asking any question.
I don't have any questions for now.
All right, so I think we just close it here for tonight. Makama, it got disconnected. So let's close it
Okay.
and let us keep on learning on our own. Every class now will resume by January when school resume for our physical class.
Okay. No.
Thanks so much. I'll try and sit and send the recording to the group.
Thank you, boss.
Thank you. Bye.